Okay, for the circuit shown below, calculate the currents I1, I2, and I3. Okay, and then neglect the internal resistance in each battery. Okay, so assuming this battery doesn't have any internal resistance, okay, and then we need to find current I1, I2, and I3. Okay, good. So this considered to have two circuit. Actually, there are three loops here. Yeah, there are three loops here. You can take this as one loop. This one, the loop on top, the loop above is one loop, and then loop below is one loop, and then the whole thing, yeah, the outside loop is another loop. So there are actually three loops here. Yeah, it looks like two loops, but actually there are three loops. Okay, so we need to find the currents, all the currents. Okay, as I said before, for two loops or three loops, yeah, two loops or three loops, there will be three currents. Yeah, unlike the example before, it's only one loop, only you have one current. Now you have two loops, means you have three current, I1, I2, and I3. Okay, and then you're going to use there will be junctions. Yeah, there will be junction there. So you can apply the formula total current in, total current out. That's the first law. So you can apply, you can get one equation from there. And then for second law, there will be three loops available. Yeah, there will be one loop, two loop, three loops available. So since there are three loops, you can build three equations, but you're gonna choose only two equations to do simultaneous equation. Okay, so I want to write that down. Okay, so now you have two or three loops now. Yeah, over here. So you will have three currents. Yeah, we have three currents: I1, I2, and I3. Okay, and then you're going to use the first law to, and then you can build one equation from here, and then the second law. Second law, you're gonna build you're gonna have three equations, but you only choose two equations to do simultaneous. Yeah. Same the method always, you must label first. Yeah, you must label first, then you build equation for first law, build equation for second law. In the end, you solve. Yeah, solve. So label first, then you do the first law, then you do the second law equations. In the end, only you solve. Yeah. So what you label, you need to label the EMF direction, you need to label the current direction, you need to label the loop direction. That is all about label. Okay, we always start with label first. That is the first step, because we are, we're gonna use this label, the EMF direction, current direction, loop direction, to determine the equation for especially the first law and second law. Okay, we're gonna use we need the direction of all these to build equations later on. Understand? Okay, so let us begin. Yeah, let us begin. So first of all, label the EMF directions. So EMF directions, like always from negative to positive. EMF is always from negative to positive. So okay, maybe negative to positive. Okay, that's the EMF directions. Okay, negative to positive. Okay, to the left. And then for E2, also from negative to positive, but this one is opposite direction. Okay, negative to positive, that's the direction of E2 to the right. And then for E3, also from negative to positive, direction is to the right. Okay, from negative to positive. Okay, so we have done label the EMF. Now label the current. Label current at where? Label the current at all the resistor and internal resistance. Okay, internal resistance. But this battery, you say neglect the internal resistance, so can consider all the battery doesn't have any internal resistance. Yeah, so there's only external resistance available. Okay. Also label the current near the junction. Also label the current near the junction, because we're going to need the current direction at the junction to determine current in, current out, to build equation for first law. Okay. So label the current at resistor, label the current at junction, label the current at internal resistance. Okay, so now label the current. So where's the current? Okay, where's the current? So look at I1. Okay, I1 is how to label, yeah? Okay, I1 yeah, always current flow from positive to negative, yeah? So looks like this. Okay, actually current direction, you draw the current direction wrongly, never mind, because the current direction, if you draw the current direction wrongly, in the wrong direction, later on the answer will have negative value, showing that the current actually is in the opposite direction. Okay, so you draw the current direction wrongly in the diagram, never mind, because your final answer later you calculate there will reveal the actual current direction. Okay, so don't worry, you draw the current wrongly, but we normally says that current always flow from positive to negative. So we look at this E1 15 volt, positive terminal is over here, so current should actually come out from here. So I1 actually is produced by E1. So let's label it. So this current I1 coming out from positive terminal. Okay, so entering I1 entering this junction. Okay, label this as junction. We can label this as junction A. Label as junction A. Okay, and then this one is junction B. Understand? Okay, so this one I1 here entering. So this current actually also must come out from B lah. Must come out from B. I1 enter A, but I1 come out from B. I1 come out from B. As I said, current you need to label at the junction. Understand? So you need to label I1 at junction A and also junction B. So I label already. Current I1 going in junction A, current I1 going out from junction B. And then label the current at the resistor. Current I1 passes through resistor 1. So passes through resistor 1. So this is I1. Passes through resistor 1. So direction of the current I1 is this way, going out from B, passing through R1, then passing through the battery, and then entering A. Understand? So I1 is over here. Understand? This I1. Okay? I1. So now label the direction of, okay, so this I1, this I1. Now label direction of I2. I2, okay, also from negative to positive lah. Also from negative to positive. So I2 is going to the right. Yeah, I can say current. Okay, label the current at the junction. So current I2 coming out from junction A, and then from negative to positive, and then I2 entering junction B. I2 entering junction B. Okay, entering junction B. As I said, this and then this current passing through resistor 2. Passing through resistor 2. So label also the current near the resistor. So resistor 2 already have the current I2. Current I2 passing through. So this current I2, why to the right? Because follow the EMF2 direction to the right also. Because current always flow from negative to positive. Okay, so that's the direction of current I2. I2 is at the second circuit here. Okay, maybe let me label. Okay, okay, so I2 is over here. Understand? I2 is over here. Now I3. Okay, I3. So direction of I3 is also follow this EMF3 direction, negative to positive. So I can say I3 is negative to positive. Okay, label the current near the resistor. Okay, label the current near the resistor. So over here lah. This is I3 passing through R3. Okay, so R3 already have the current I3, and then okay, so resistor 3 already have the current I3 passing through. Yeah, already label the current at the resistor 3, and then this current I3 of course going from negative to positive terminal, and then this current label the current near the junction. Okay, so the I3 will enter junction B, this I3, and then where this I3 come from? It must come from junction A, so label the current at the junction A also. Yeah, so current I3 coming out from junction A. So this is where the current I3, yeah, at the third circuit here. So I want to highlight I3 come out from A, passing through R3, passing through the battery, and then enter the junction B. Okay, so that's I3. Now you already label the EMF. I already label the EMF, and also label the current at the resistor and all the resistor. So all the resistor already have current to refer to, and the junction also have all the current in, current out, current in, current out. So I can use this current direction later on to build equation for first law. Yeah, and also direction of EMF and direction of the current at the resistor to build equation for second law. Now I need the loop direction. I need to label the loop direction because later on I need to compare the loop. I need to use a loop law. I need the loop direction to compare with EMF direction and also the IR direction to know whether it's positive E or negative E, positive IR or negative IR. So I need the loop direction. Understand? I need the loop direction. So which loop you're going to choose? You're going to choose only two. You're only going to choose two loop direction. Okay? You're going to only choose two direction. I know there are three loops. You can either choose the top loop, or the bottom loop, or the big loop outside, excluding the middle. Excluding the middle. So any two, you want to choose the top and bottom two loop, or also can. You want to choose the top loop with the big loop, also can. You want to choose the bottom loop. You want to choose the bottom loop with the big loop, also can. Understand? Any two, only two, yeah, and only two. Not do three equation. Not going to choose all three equation. No need to build three equations. Yeah, only got out of three, only choose two loops to do. Understand? So no need to make yourself trouble. Okay. So right now, maybe I want to choose. The top loop. Maybe I choose the top loop. I choose a top loop. Okay, I choose the top loop. This one. How to draw? I use purple color. I choose a top loop going from this way, this way, this way, this way. This one as my as my loop 1. This one as my I put as L1. Means loop 1 lah. Loop 1. I choose the top loop. Yeah. And then another loop I choose. Why? Okay. Why I choose my loop anti-clockwise instead of clockwise? Because I try to make my loop direction follow the current and EMF, so that you will have more positive E and more positive IR. Understand? So I purposely, you see, because I saw this E1 and E2 and all the current I1 and I2 all anti-clockwise. You see that? Anti-clockwise. So I choose my loop 1 also all anti-clockwise. So later on, all the EMF and all the IR will have positive value, will be positive E and positive IR. Then my equation looks nicer. Okay? Okay, that's my loop 1. Okay, do I want to choose the bottom loop? You want to choose the bottom loop? Also can. Also can. But it looks like this current about a bit more complicated. Later on, you will have negative opposite direction, you have same direction, so you have mixture of positive and negative value, isn't it? So I don't want to choose bottom one. I choose the outside loop. Alternative, you want to choose the bottom loop also can, no problem. But I want to act more intelligent. I choose the outside loop, also can solve, yeah, because the outside loop looks like all the EMF and all the IR, I1, R1 and I3, R3 all in the anti-clockwise direction. So I choose the outside loop. The outside loop. Okay, that's my loop. Consider my loop 2. Okay, that's my loop 2. So I have 2 loops, 1 loop and 2 loops. And you want to choose the bottom loop also can. No problem one. Still can solve. Yeah, you want to put the bottom loop as clockwise loop also can. Yeah, also can. You still get back the same answer later on. You still get back the same answer. Current I1, current I2, current I3. You still get back the same value. Okay. But right now, this is what I like. I want to choose the top loop and the outside loop. I do what I like, isn't it? My freedom. Okay. So okay. So right now, okay, I've done label. I've done label the loop already. I've done label the EMF. I've done label the current at all the resistor and all the junction and internal resistance, if there's any. And also I've done label the loop direction. So now I can easily build equation for first law and second law. Now is the second step. Do the first law. Yeah. Now is the first law. Build equation for first law. Okay. Now let's do the questions. First law. Right. First law. So my first law is current in, current out. Current in, current out. So for this one, this is called the junction law. Yeah, junction law. I need to choose a junction. Yeah, first law is about junction law. So I need to choose junction. I want to choose junction A or junction B also can. You will get the same equation. Yeah, still you get back the same equation. But I only choose one equation. Yeah, first law only do one equation. So only one junction only enough. You want to choose junction A or you want to choose junction B? Just one junction enough. Okay, right now I just choose junction A lah. Okay, I choose junction A. I choose junction A. Yeah, junction A. Write down the junction A over here. And then current in is what? What is the current going in? I1. So put I1 there. And then is there any more current going in the junction A? No more. Okay, now look at current going out from the junction A. Is I2 and I3. I2 and I3. So I2 plus I3. I2 plus I3. That's the one equation already. I got one equation already. Okay, easily. So why I can build this equation easily? Because I done my first step. I label my current at the junction. So with this label, I can easily build equation for my first law, current in and current out from junction A. Easy, isn't it? You want to choose junction B also can. You see, if you choose junction B, what's the current going in? Current going in is I2 and I3, isn't it? So it's I2 plus I3. Then what's the current going out? Current going out is I1. Going I1. Is this the same equation? I2 plus I3 equal to I1 with I1 equal to I2 plus I3. Is it the same equation? Same, isn't it? So you don't need to do two junctions. Just do one junction. Enough. Yeah? Because it is a repetitive of equation. Okay? So no need to do two. Just do one. Understand? One enough. Because it's the same equation later on. Okay. So I done my first law. Now, my third step, second law. My third step, second law. Okay, my third step, second law. So for third step, second law, yeah. Second law, that's my loop law. Loop law, okay. Loop law is about total EMF equal to total IR. Total EMF equal to total IR. So for this one, okay, so for this one, I need to choose 2 loops out of 3 loops. You have 3 loops here, top loop, bottom loop, and the outside loop. So for this case, because I want to make, get as many positive value as possible, I choose the top loop anti-clockwise and the outside loop anti-clockwise. Yeah, my first loop is the top loop, my second loop is the outside loop. Okay, so I begin with the first loop. Okay, I begin with the first loop, L1. Okay, first loop, and apply the total E equal to total IR. Okay, so remember, now look at total E. Total E. So just look at the battery. Yeah, battery inside this first loop. Okay, first loop here means I going from, I going from this point. Let's say I going to from this point over here. I label. I going from, let's say, from this point over here, and then I go down to junction A, and then from junction A, I go anti-clockwise. You understand? That means it's like I travel from this point going to junction A, and then go to the right to junction B, and then go up. Yeah, go up and then go through resistor 1 and go through battery E1 and back to this point, to the same point. That's loop 1. That's what I mean by traveling anti-clockwise in the top loop. Understand? Going from this point, going down to junction A, passing through E1, passing through resistor 2, arrive at junction B, go up, passing through resistor 1, passing through EMF 1, back to the same point. That's a one closed loop. So it must have a closed loop. You understand? It must have a, what do you say? A closed. This loop 1 must be a closed loop. This loop must be a closed loop. It cannot be an open loop. Understand? If this loop is open at somewhere, there's no current, and then you cannot apply the loop law. Understand? It must be a closed loop. You must return to the same point. Okay? Then you can apply the loop law. Alright. Now, okay. Looking at this top loop. Okay, so look at the EMF. How many battery do we have in this top loop? We have 2 batteries, isn't it? 2 batteries. So we have E1 and E2. Now look at, is it the EMF same direction with the loop or opposite? If same direction, you get positive E. If opposite direction, is negative E. So, okay. Now look at the E1. E1 is to the left. Negative to positive to the left. And the loop at the top here, is going from right to left, isn't it? Going to the left. So the loop is to the left. The EMF direction also to the left, same direction. So this E1 is positive. Actually, the positive sign you no need to write also can. Yeah, but I purposely put positive here for clearer explanation. Okay. And then, okay, done with E1. How about E2? E2 is going to the right, negative to positive, going to the right, and the loop direction is to the right, yeah, to the right from junction A to junction B, as drawn here. You see, loop direction is to the right, EMF also to the right, same direction, EMF same direction with the loop. So EMF same direction with the loop is positive E. So E2 also positive E. So E2 also positive E2. So I'm done with the 2 EMF, done with the 2 battery. Now look at the resistor. So in this loop, in this top loop, how many resistors are there? There are 2 resistors. There are resistor 1, and resistor 2. Okay, there are only 2 resistors. All right, 2 resistors. So resistor look at current. That's why I need to label the current at the resistor, so that later on to determine the IR, I will have the current to refer to. Yeah, I will have the current to compare with the loop direction. Understand? Okay. So resistor 1, what's the current passing through? I1. It's the I1 passing through R1, not I2, not I3. You must know where is the current. I1 is at the yellow circuit here. I2 is at the blue circuit here. I3 is at the green circuit here. So the I3 is not in the other yellow or blue circuit. Same as I1 is not at the blue or green circuit. So you must know what current passing through R1. Is I1 passing through R1. It's not I2 or I3. It's only I1. Okay? Don't get wrongly. So current passing through R1 is I1. And I1, okay, compare the current direction with the loop direction. Okay, if resistor, we look at the current. If battery, look at the terminal from negative to positive. If resistor, look at the current. And the current for R1 is I1. I1 is going to the left, isn't it? Going to the left. And current is same direction with the loop. Loop also going to the left. Loop also going to the left. Current going to the left, loop also going to the left. So when current and the loop same direction is positive IR. So this I1 R1 is same direction with the loop, so is positive. Positive I1 R1, positive I1 R1. Okay. And then how about the resistor 2? Okay, resistor 2. Look at current I2. Look at current I2. Current I2 is going to the right. You see, resistor 2 is the current I2 passing through. This current I2 is same direction with the loop. Loop also going to the right. You see that? Look at the bottom, bottom part of the loop, not the top part. Look at the bottom part of the loop. Bottom part of the loop L1 is to the right. To the right. This current I2 also to the right. To the right. So current same direction with the loop. So this I2 R2 is positive. When current and the loop same direction is positive IR. Understand? So it is positive I2 R2. Positive I2 R2. Okay? So I'm done with the equation. Is there any more resistor in this top loop? No more resistor. So total IR is done. Total E also done. So that's the equation. Now you just substitute the value. E1 is 15 volt. Okay. So label it. Yeah. Okay. Substitute the value is 15 volt. And then for E2 is 10 volt. Okay. Plus 10 volt. And then I1, I don't have the value. R1 is 1 ohm. R1 is 1 ohm. Put in the value. And then I2 is, what's the value for I2? R2? 0.5 ohm. 0.5 ohm. Okay, so my equation later on will become 25 volt equal to I1 plus 0.5 I2. That's my second equation. Can I solve it? Can I straight away find I1, I2? Cannot. Because you have two variables. So you need another loop. You need another equation from the Kirchhoff second law. Understand? So I need another loop, which I choose the outside loop, the loop 2. Okay. Okay. So loop 2. Now I go to need another. So for second law, I need to do two equations. Yeah, do two equations. So I already have one equation. I need to get another equation. So which is the loop 2. Okay, it's also a closed loop. It is also a closed loop. You see that? It's also a closed loop. So for loop 2, actually is like, let's say I go from this point. Okay, I go down. You know, it's the loop is like go down, go to the right, go up, and then go back to the same point. Go back to the same point. So it's like going from this point, going down, going right, going up, and then go to the left, back to the same point. That's the loop direction for loop 2. Loop direction. So later on, compare this loop direction with the EMF direction and the current direction. If same direction is positive, if opposite direction is negative. That's all. Understand? Okay, so loop 2. Okay, loop 2. Okay, look at loop 2. Look at total E. Okay, look at battery. Is there any battery in loop 2? So for loop 2, ignore the center circuit, the blue circuit. Ignore the blue circuit because we didn't go through the blue circuit. The outside loop is just going outside the loop. It doesn't go through the blue circuit. It only go through the yellow and green circuit. Yeah, only go through the yellow and green circuit. So ignore the battery, ignore the resistor at the second circuit here. Understand? Only take the first circuit and the third circuit here. Only take the yellow and the green circuit here. Understand? So the total EMF, only look at the outside circuit, which is only the E1 and E3. E2 not involved. Not involved. Understand? Okay. So now, so there's E1 and E3. Okay, now look at E1. E1, okay. E1 is to the left, negative to positive. Compare the loop direction is also to the left. Also to the left. So same direction, isn't it? So it's positive. So when EMF and the loop same direction is positive E. Okay, now so write it down. So it's positive E1. Okay, positive E1. If you are expert already, later on you just straight away put the value here. Understand? But now you are beginner, you just put the letter. Okay. Now, so how about E3? We done with E1, so another battery is E3. E3 is negative to positive to the right, and the loop direction also to the right. To the right. You see that here is to the right. So it's same direction. Same direction is also positive E3. So it's positive E3. Okay. So I've done. So EMF 1 and EMF 3 I've done. So no more battery involved. So now look at total IR. Total IR, look at the resistor. So how many resistors are there in the outside loop here? Yeah. Okay. Resistor 2 not involved. Not involved. Yeah, because we are not passing through the blue circuit. We are using only the yellow circuit and the green circuit. Okay, so it's only R1 and R3. R1 and R3. So R1, okay, R1, look at the current. That's why I label the current at the resistor. The first step is so important. If you don't do the first step, then you very hard to know what current passing through R1. Okay, okay, so R1, the current passing through is I1. This I1 is in the same direction with the loop because I1 is to the left. The loop direction also to the left, same direction. So when loop and current direction same direction is positive IR. So it's positive IR. Okay, so it's positive I1 R1. Understand? Okay, done with R1. Now, what are the other resistor involved? Resistor 3. Okay, resistor 3 is at the outside loop. So resistor 3, what is the current passing through? I3. I3 passing through. I3 is to the right. To the right. And this I3 is in the same direction with the loop. Same direction. So same direction means positive also. So it's positive. So it's positive I3. R3. So that's why I choose the loop direction anti-clockwise rather than choose that loop direction clockwise. I choose it anti-clockwise, so you see all I get is positive value. Then easy for me to solve. But if you choose a loop direction clockwise, also can. No problem. You just get all value negative. Negative value are very hard to deal with. Yeah, sometimes you make mistake. Yeah. Okay, so that's the way. I think I have covered all the resistor, right? R1 and R3 only. Yeah, only R1 and R3 at the outside circuit. There's no more other resistor, right? No more other resistor. So there's only two IR. Yeah, I1 R1 and I3 R3. So only two. Okay, so done it. Yeah. So now substitute the value. Yeah, done. We're done with total IR already. So now substitute the value. Okay, what is the E1? What is the E1 value? E1 is 15 volt. E1 is 15 volt. And then what is E3? E3 is 3 volt. E3 is 3 volt. And then I1, R1, what is R1? 1 ohm, 1 ohm. And what is R3? What is R3? R3 is 0.1 ohm, 0.1 ohm, 0.1 ohm. Yeah, R3 is 0.1 ohm, 1 ohm, 0.1 ohm. Yeah, 0.1 ohm. Okay, 0.1 ohm, 0.1 ohm. Okay, so I done. Substitute all the value already. All positive, very good. So now put in 18 equal to I1, and then 0.1 I3. Okay, so done ready. Okay, I got the equation, another equation already. So this is another third equation. Yeah, so for second law I got two equation. For first law I got one equation. So there are three unknowns: I1, I2, I3. I1, I2, I1, I3. So there are three unknowns. I have three equations. Yeah, so that means if we have three unknowns, okay, you have three unknowns, then you need three equations to do simultaneous, isn't it? Then you need, if you have three unknowns like I1, I2, I3, I1, I2, I3, I1, I2, I3. That's why you need three equations to do simultaneous. So that's why I built three equations to solve it. If I don't have three equations, I cannot get the value of these three unknowns. If three unknowns, you must have three equations. You have two unknowns, you must have two equations. That's how we do it. That's why for first law I do one equation, for second law choose two equations. Then I definitely can find this I1, I2, I3. That's the way to do it. But then how to solve? Do I need to use the simultaneous? Do I have to use the substitution method? Or I need to use the elimination method? That means, what is this elimination method? Elimination method and substitution method. That means I choose the equation 2 minus equation 1, then left with two unknowns, and then minus again, or substitute. A lot of steps, isn't it? A lot of steps. So now we don't do this to do simultaneous equation. To save time, to save time, we use scientific calculator to help us. We use scientific calculator to help us to calculate, to save time, and then to reduce error also, to reduce error and to save time. Yeah, if this one a lot of steps, to save time and reduce error, we use scientific calculator to do the work of simultaneous equation for us. And what is the steps to do it? I show you now. Okay, very easy. Okay, what you have to do is, okay, now you have three equations. You see that? Highlight the equations. Yeah, you have three equations. Yeah, here you have one equation, and here two equations, and then here the third equation. You see that? Oh, sorry, didn't highlight everything. So you have three equations here. So how to work with these three equations? Okay, so to use a scientific calculator. Okay, now we are in the part 4. We are going to solve it using the scientific calculator. Using the scientific calculator to help us. Okay, so what we're going to do is we need to arrange the equation first. So now I need to arrange the equation first. Arrange the equations. Okay, so how to arrange? Okay, how to arrange? Okay, put equation 1 at the, here. Okay, arrange I1, I2, I3 in sequence. Okay, so arrange it. So we have here I1, so arrange this one is I1, okay, and then this I2 and I3 go to the other side, become negative I2, negative I3. Negative I2, negative I3, and then this side becomes 0, the other side becomes 0. Put it I1, I2, I3, that sequence. And then equation 2 also arrange I1 first, and then followed by I2. I2 is 0.5 I2, but you don't have I3, isn't it? Don't have I3, never mind. Put in this one, plus 0 I3. This one you have to add. You have to make all available. You have to make all I1, I2, I3 available. If you don't have I3, put 0 I3. Understand? Put 0 I3. Okay, done. And then this one is 25. That's the second equations. Okay. Now the third one is okay, this one is I1 and then plus, okay, you don't have I2, isn't it? You don't have I2, so you put in 0 I2. Put in 0 I2. Put in 0 I2. Okay, 0 I2. 0 I2 and then followed by I3. So plus 0.1 I3. Always follow the sequence 1, 2, 3. Yeah, I1, I2, I3, I1, I2, I3, I1, I2, I3. Understand? And then equal to this one equal to 18. Okay. So now what you need to do is you punch into your calculator. How are you going to do it? So choose let me see, choose the in your calculator, yeah, in your calculator, choose the mode, yeah, choose the mode, choose the equation, number 5 equation, yeah, choose the number 5 equation, and then choose what? Choose the number 2. Number 2 got what? The what? Something like x, y, z, and then equal to, you know, a, b, c, d is something equal to something lah. That one. Yeah, choose the number 2. Then you saw something like a, b, c there, and d. Then you put in the value there. Yeah, you punch in the value there. You know, punch in the value there. Punch in the value there. Punch in the value there. You know, this one is, this A is for I1, this B is for I2. Yeah, I mean the constant for I2, this C is for constant for I3, and then this is the number. This is the number in the end. Okay. So punch in the value there. Punch in the value there, and punch in. Okay, like you see for equation 1, this is punch in 1. And then I2 you punch in negative 1, and then I3 you punch in negative 1 also. For equation 2, this one positive 1, and then 0.5, and then 0, and then 25, and then equation 3 you punch in positive 1, and then 0, and then 0.1, and then 18. Okay, let's punch in together. Okay, so punch in now, punch in. Okay, I start with equation 1, I punch in 1, then I punch in negative 1, then I punch in negative 1, and then 0. Okay, wait, let me see. Okay, 0, okay, 0, okay, and then 2. Okay, 2 you punch in, okay, equation 2 you punch in 1, and then punch in 0.5, and then and then you punch in 0, and then you punch in 25. Okay, hey, wait, again, yeah. Okay, continue, yeah. So punch in 25 already. Now go to equation 3, punch in 1, okay, and then punch in 0, and then punch in 0.1, and then punch in 18. Solve it. Enter, solve it. So your answer you get, okay, so you will get the answer immediately. No need to do any simultaneous equation. So I1 you will get 17.69 ampere, and then I2 is I2 is 14, 14.62 ampere, and then equation 3, I3 is 3.08 ampere. That's the answer. And sometimes this answer you will get negative value. Sometimes what I can say is sometimes this equation, you maybe, let's say I2, maybe you get answer, maybe you get negative 14.62. If you get, sometimes if you get negative value, what does it mean by the negative value here? What does it mean by negative value here? It means the actual current, direction is opposite from direction drawn. Direction you draw on the circuit. The current direction is opposite from direction drawn. So what it means here is what I mean just now. Is also what I mean just now. If you draw your current direction wrongly, also never mind. That means sometimes some students, they draw the direction of current I2. Let's say I2, he draw direction not to the right, he draw the direction of current to the left. I draw direction current to the left. So which is the wrong current direction? But if you draw wrongly, never mind, because the final answer will reveal the actual current direction. Will reveal the actual current direction. If you draw direction to the left, here you will get a negative value. Negative value here means the actual current direction is actually opposite from what you draw. Opposite from what you draw. You draw the direction of current to the left, but actually the actual current is opposite from direction you draw. That means the actual current is actually to the right. It's actually to the right. So the actual current direction is actually to the right. So that is what it means by negative value here. If you get it, if you get a negative current, okay. But right now I get a positive value, right? I get a positive value for all the current. In fact, I get positive value for all the current. That means what I draw here, the current direction I draw here is all correct. It's all correct. It's all correct. So there's no wrong. There's so that means all the current direction I draw here is all correct. The actual current direction is the one I draw. The I1 is going this way, the I2 is going this way, the I3 is all going this way. So the current I draw is in the correct direction. But if you get a negative value, that means the direction you draw is wrong. The actual direction is actually in the opposite. Okay? So right now I got all the current direction correct, in the correct direction. So never mind. Understand? If you get the direction, you draw it wrongly. If you draw the direction, let's say like just now, if you draw the direction I2 to the let's say to the left, and then you get the answer negative, means the actual direction is to the right. Okay. What I can say is, don't change your answer. What you draw, you must maintain the direction there. Maintain the direction there. You don't change your drawing. Because why? Your negative answer, negative current, is based on what you draw. Don't change it. Let's say you know already the actual direction is to the right, but you draw to the left. Oh, then you suddenly act clever. Act clever, you rub it off, and then you draw the correct direction to the right. Don't do like this. You will confuse the examiner. You confuse the examiner because your negative answer is based on your wrong direction. It's based on your wrong direction to the left. If you change it back to the correct direction to the right, then your actual direction, what you draw is to the right, but then you answer negative means the actual direction is to the left. You confuse the examiner. What I say is, if you draw wrongly, leave it there. Leave your diagram like that. Leave your diagram like that, and let the final answer to tell the examiner the actual current direction. Don't change your drawing. Understand? Don't ever change your drawing. That's it. Let your let your diagram wrong, never mind. Let your diagram wrong, never mind. But let your answer be correct. Understand? Okay, that's what I want to say about the for solving Kirchhoff law for 2 or 3 loops. Understand? So is my answer correct? Let's check the answer together. So I1 is positive 17.69. Yes, that's correct. 17.69, that's correct. And how about I2? I2 is 14.62. 14.62, that's correct also. So good, scientific calculator, solve it for me. And then I3 is 3.08. 3.08, I3, is it correct? 3.08, that's correct also. So my working is correct. Everything, yeah? So this is Kirchhoff law, Kirchhoff rule. Yeah, hope you understand, you like my channel, and subscribe, and please share to your grandchildren and grandson, granddaughter, and your relatives later on. Yeah, okay, thank you, bye.